Morning guys, so we are going to briefly look at the index laws or law of indices, whichever, today, and then you've got a task on Dr. Frost that you can just get started with. Okay, so these are the first three laws. You guys are probably quite confident with these, I hope you are. So you have the multiplication law, so where you just add the powers, you have the division law where you take them away, and then you have the bracket law. So if you just want to pause and then see if you can get these answers. So I'll run through them one by one for those people that don't feel so confident, but if you do, pause and then obviously just whiz through, see if you got the right answer. Okay, so for these questions, I've got a to the power of 3. I'm going to square that times 2a to the power of 2. Just like order of operations, what do we do first? We do the brackets first. So I need to do the brackets, which is the bracket law. So I need to multiply these powers. So it becomes a to the power of 6, multiply a to the power of 2. Okay, ordinary numbers are left as they are. Don't have to multiply it by anything. So 2 just stays at 2. And then we have to multiply the actual index numbers with the indices law. Okay, so we add the powers, makes it a to the power of 8. Okay. Next one, we have 4x to the power of 3, y to the 3. Okay, so for each of these, we are just applying that power to each of the terms inside. So I've got 4 to the power of 3, I've got x to the power of 3 to the power of 3, and then I've got y to the power of 3. So this one will then become 64. This need to multiply 3 by 3 is 9, and then y to the power of 3 stays as it is. Okay, next one. 2x squared, open bracket, 2x to the power of 5, take away x, 4, take away x squared. Okay, so first of all, I just want to expand the brackets, then I can start collecting the terms. So this one, ordinary numbers, 2 times 3 is 6, and then we've got the x squared. Ordinary numbers, 5 times 2 is 10, x times x to the power of 2, add the powers, so we've got x to the power of 3. This is 4 times the x, and then I've got the 2 negatives, so that makes the positive, and then I've got x squared times x, which is x to the power of 3. This is the only one that has shared terms, so I'm going to collect those together. That is my answer. Okay, so some people like to go ascending or descending powers. Doesn't really matter. Technically, this is correct. Okay, it might help if they ask you to factorize it, just to put them in ascending or descending, because then it makes it easier to kind of think about product sum and everything else. But if they don't ask you to do that, don't worry too much about it. Okay, last but not least, just so it doesn't get mixed up with this, we have x to the power of 3, take away 2x all over 3x squared. Okay, so for this one, what you might want to start doing just to get into practice of it, especially if you're thinking about the A-levels, and especially with differentiation, where you do just want to split up the actual numbers so you can differentiate each individual term. So obviously the denominator, I can't split up the denominator, but I can just repeat the denominator for every single term that is for the numerator. So I've got 2 terms up here. So I'm going to say x cubed, take away 2x, but then this is going to be its own fraction, and this is going to be its own fraction. Okay, and then once we have these two separated, then I can actually start cancelling stuff out. So this is x squared, so that cancels that out, and that cancels that out, so it becomes x over 3, take away 2 over 3x. Okay, if you were thinking in powers of x, just before differentiating, you would have this. Okay, but that'll be the next step. If you got this far, that's fine for now. Okay, so these index laws is usually the ones that people have a little bit of difficulty with. To the power of 0, sometimes people do forget that it is just equal to 1. So that's, I would probably say that's quite an easy one to remember, but it's quite an easy mistake to make when you're in the middle of like high pressure stuff. So just keep an eye on that. And then you have this fractional rule. Personally, if you want to learn less laws, just learn this one rather than the both of them. And then all you have to do in order to make this into the second one that's quoted over there is just say if n equals 1. So if n equals 1, then it's just this. Okay, and then anything to the power of 1 is just itself. So I can actually just get rid of the brackets when that happens. Hopefully that makes sense, but this is just derived from that. So it's all entirely up to you. So it's from here, you can probably, using this one, you could say a to the power of a half is 2 square root a 1. Okay, this is one way of thinking about it if you can't remember about like square roots, cube roots to the root 4 or anything else. And then you have the negative power as well. So just any time you have a negative power, you take the reciprocal of whatever this number is. So it becomes this. And then you just make it a positive power. Okay, does that make sense? So whatever the number is, you just take its reciprocal and then it becomes a positive power. They're just putting 1 over there instead. Okay, so going over these questions. Okay, so the first question is actually asking you to prove. You have to remember that these laws actually come from proof. So you can't use the laws in order to prove what you're doing. So you have to prove the law. Hopefully that makes sense. So if you just think about the multiplication law where I've got a n times a to the power of m equals a n plus m. Yeah, everyone remember that? So what if I said that these two had to be the same power? So in order to make them the same power, I could then say this because n plus n would then be 2n. Okay, but I don't want the power to be 2n, I want the power to be 1. So if I made this to the power of 1, these two are only half of this. So this must be to a half, and this must also be to a half. That would be logical. Okay, and then that would be 1/2 of the proof. So I've got to a to the power of 1, so which is just a. Okay, and then for the next part, you just need to think about your thirds. If I have this, then that is also a. Right, if I have square root of something times the square root of something, that's also a. And then I can say, well, these two are exactly the same. So if these two are exactly the same, that must mean that these two terms must also be exactly the same. So then from that, you could say that they are equal to one another. Okay, and that's a 2, and this is all to the power of 1. So this is one way that people prove that law right there. Okay, so the next one, it says 27. Ooh, okay, sorry, that pen's out of ink. Let's get another pen. Oh, there you go, better. Okay, so we have 27 to the power of negative a third. So first thing you want to do is always get rid of that negative. You don't really want to be working with negatives. So I've got to do the reciprocal of this first of all. So 1 over 27, and then it's going to be to the power of a third. So cube root of 1 is just 1, and then cube root of 27 is 3. Okay, if you're not aware of the cube root of 27, you can always use your calculator in order to find it out. You do just have, oh, where's the button? Yeah. Okay, so the button is right here. You'll notice it's one of the shift ones, so when you put it on, you just have to go shift, that one, and then just make sure you put a 3 there and a 27 there. There you go. Okay, so if you didn't know it was, you can always use your calculator. Okay, so that's how you would do that one. The next one is 32 to the power of 2 root 5. Okay, so that's positive. So I just want this squared. Okay, so use your calculator if you don't know this, but it's a power of 2. Some of you might recognize it, especially if you're interested in binary. So that would be 2 squared, which is 4. Okay. And because you guys don't have non-calculator papers, feel free to use your calculator. No one's going to worry too much about it. Okay, so for the next one, got 1 over 9 x to the power of 6 y to the power of a half. Okay, so for each term, I get this to the power of half, this to the power of half, and then y to the power of a half. Okay, so for this one, square root of 1 is just 1. Square root of 9 is 3. This is to the power of 6. 6 times a half is 3. And then y to the power of a half. So hopefully that should make sense. You've got 27 over 8 to the power of negative 2/3. So the first thing I want to do is take the reciprocal of this fraction. So flip that fraction around. So I've got 8 over 27, then 2 root 3. Okay, so now I need to find the root 3 of both of those. So cube root of 8 is 2. Cube root of 27 is 3. And then I just need to square it. So it's 4 over 9. Okay. And last but not least, sometimes you are asked these types of questions where they have one form of something and they want you to find it in a different form. They kind of give you the answer, so you know the answer is going to be a number, and then it's a to the power of another number. Okay, so they've got b equals 1/9 a squared, and then they are saying you need to find out what this is in terms of this. Okay, so instead of b, I'm going to put this. So I've got 3, and I've got 1/9 a squared. And then this to the power of negative 2. Personally, otherwise you can start doing it all at once. Me, personally, I like putting it straight into fraction form because then I can just find the reciprocal, especially when there's a negative, rather than thinking about everything individually and doing it all at once. Just doing it individually, I can just do it all at once. So I'm going to say this is a squared over 9 to the power of negative root 2. So to get rid of that negative root 2, I just want to take the reciprocal of that, which is 9 over a squared, and then just say root 2, and then I can just times everything quite easily. So I've got 9 squared, so that makes it 81, all over a squared to the power of 2. So 2 times 2 is 4. Okay, this is 2, 4, 3 over a to the power of 4, but obviously they've asked a to be above, so they need to know what the actual power is. So that would be 2, 4, 3 a to the power of negative 4, because it's one of the negative powers. Okay, hopefully that should make sense. So I have popped a quiz onto Google Classroom, Dr. Frost, sorry. So you can always go onto there in order to do the quiz. It's also got videos on there if you get stuck on any questions. But if you do prefer to use like my iMaths or anything else, just to check out how to use negative or fractional powers, then you can do that as well. I just essentially need evidence that you've been going through some of the work. So I've set something on Dr. Frost. There will be videos. If you get anything wrong, you do see the video and then Mr. Frost will go through it. But otherwise, can you just go on to Dr. Frost? Unless you let me know, I'm just going to assume everyone's going to go on to Dr. Frost. Okay? So take care. Let me know if you have any queries.